Hey guys, and welcome back to Dan's Pro Shop. I'm your man Dan. Today we are fixing this big old chunk of oh man, extinct machinery, if you will. This is a return pipe for a hydraulic system on an injection molding machine. Now, I know a lot of you might be saying like, hey Dan, if this thing doesn't exist and you can't get a new one, why don't you just replace it with a piece of hose? Well, man, if I could, I would have. I promised you. I fixed this thing probably about 5-6 years ago, and she let go again. But don't fret. We have the technology. So I'll bring you in and give you a better clue on what's going on here. So guys, like I mentioned, here this is. It's just a solid, weird chunk of geometry and hydraulics. This is an odd situation. This comes off of an early 90s LG Gold Star IMM. And if you guys don't know what that is, injection molding machine. That's just slang we use in the industry. But unfortunately for myself, this machine and that division of that company and everything went extinct a long time ago. So procuring new parts for this thing, it doesn't happen. They don't exist. So whenever something happens on this old boy, it's figure it out or you're screwed, right? So luckily, we got a little bit of fab going on. And this particular thing here, it's just a solid chunk of iron. We got a tube bent in a bunch of weird shapes, a solid block on one end, a solid block on the other end with a tap for a hose. But luckily enough for us, this is on the suction side of the system or the return side of the system. So if you guys are familiar with hydraulic systems, whenever oil gets used in a system, going through valves, doing work or whatever, it will inherently pick up heat. That's just the physics of a hydraulic system. The oil heats up. Well, we need a way to cool that oil, or else it would just keep heating and heating and heating until it just becomes a bloody nightmare. Believe me, if you ever have a plugged heat exchanger, you know exactly what I'm talking about. But speaking of heat exchanger, this block right here bolts onto the return side of the main valve manifold on the back of the machine, goes through these weird angles because that's where they had to put everything. I don't know. Comes down to this block, a wee little hose, and this main fitting here goes to a different pipe that goes to the main heat exchanger for the machine. So what's going on here is just over 40 some years of this thing just beating the crap out of itself all day, every day in a manufacturing environment. If you guys are familiar with injection machines, they actually do kind of stretch. When you push 500 tons onto something, stuff's going to move. So since this thing is fast bolted, that's another thing. I think this is kind of a crappy design now that I'm thinking of it. This side where the valve stack is on the injection unit side of the machine. This side is on the clamp side of the machine. So whenever we're stretching and, the carriage is pressed up against the non-moving platen, there's so much tension in that machine. That's probably taking it out on this poor thing. But regardless, this thing is all iron and it is totally fixable. And I've done a little bit of scabbing on it in the past, and we've gotten through for probably about 4 or 5 years. But unfortunately, she started weeping again. So enough with me jaw jacking. I will take you out to the machine so you can physically see what I'm talking about, minus the part, obviously. But at least you'll get a better idea of what's going on. So guys, just in case you've never seen one before, this is the rear end of a 500-ton injection plastic molding machine. And if it looks like a hot mess, it's because it is. I mean, like I mentioned, this thing has been in service for a long time, and you cannot get new stuff for this thing. So it's a chore to keep non-existent stuff like this moving. But I tell you what, this thing still pumps out dollars every day. So we got to do the best thing we can to keep it rolling. So that pipe I showed you on the table in the shop connects right here to this flange that you probably can't see all very well. But this is a return pipe that goes down there to the heat exchanger underneath the other side of the machine by the hydraulic tank. The other side of it snakes all through this BS here, goes up underneath here to a port on the bottom of this valve stack. So this is the pressure line that comes from one of the main pumps over there, comes through here, gets used, does all of its stuff here for the carriage and injection and screw and all that, comes back through that line that's on the table, hooks up to that pipe, goes back to the heat exchanger and dumps back in the tank once it's cooled to be used again. So the problem that we're running into is this flange right here where this thing bolts up, where the pipe meets the flange. It's a little cracky pooed. So we're just going to grind it out, weld it up. And here's a little sidebar. Just since we're doing this project on this machine, I think this is a cool industry that a lot of regular folk, excuse my French, you know, if you haven't been exposed to this stuff, you probably might not know what this is. But if you're anything like me, and if you're watching this crap, you probably are. Manufacturing and industrial stuff, it's just cool. And like, I like to learn about stuff that I don't know. So if you are unfamiliar with IMMs, this is one. I know this is not a pretty one, but it is one, and it does it very well. So what we're looking at here, this is the injection unit. This whole side of the machine from here to here. So like newer machines, maybe not this particular one, but usually these machines get shipped in separate pieces. They would be bolted together right here. So the injection unit and the carriage is one part, and the clamp side is its own part. Because more often than not, these things come from overseas. So that's the way that they're able to fit these things into shipping containers, is that they split them in two. And that's how they get shipped, and then they are installed into one piece and lined up and everything where they go to live for the rest of forever. Now, here's a little bit better angle of the injection portion here. I know there's a bunch of guarding and stuff on here, so you're just going to have to take my word for it. And like I mentioned, this isn't one of the newest ones. So there is a lot of unnecessary BS that doesn't really happen on the newer machines. But if you'd like, I'll give you a glimpse of a newer one. So this guy is the heart and soul of the injection unit. So you guys can see here that we have a heated barrel. All of these silvery things are called heater bands. They are ceramic heater bands that are insulated with that ceramic and have electric heater elements in them that keep the barrel at a soak temperature. So depending on what kind of material or what plastic you're running, this thing will change temperature to promote plasticization or whatever. You get what I'm saying. But the material comes through this vacuum hopper that's driven by a whole house PLC system. The material comes in here into a feed throat that is also temperature controlled with water. Because if you can imagine, this thing's sitting here 450, 500 degrees all day, radiant heat. This thing will heat up, and it's unreal. So stuff will start to actually melt inside of the feed throat, and it causes all kinds of problems. So right here where the material starts to go into the top of the screw is temperature controlled to keep that from happening. So once this thing comes in here, it sits on top of a giant feed screw. So I don't know, kind of like a grain auger, if you've never seen one, to give you a little bit better, you know, I don't know, it's a giant screw. Imagine it, like if you put a drywall screw inside of a McDonald's straw. This is kind of what's happening inside of here. So the plastic sits on there, and then there is a huge hydraulic motor back here behind this panel that you cannot see. That hydraulic motor spins that screw counterclockwise. So it will actually start to pick up the material in the flutes of that screw and build back pressure. So there is a check ring at the beginning of this screw that will not allow material to come out of it unless we tell it to. Now, you can, but that gets into the science of processing. Let's just keep this simple. So as we build back pressure with the screw turning, this whole injection unit moves back. So it is pulling the screw back through the barrel with hydraulic cylinders and that motor spinning at the same time. Now, while that's happening, all of this plastic is falling into the screw, so it is loading the next shot. Once you reach your set point and do whatever you want to do, then it is time to inject. So once the clamp portion is closed and we've reached tonnage, don't worry, I'll get you over there. Everything is good, the machine is satisfied, everything's up to temperature, and our shot is made. Now, it engages these two giant hydraulic cylinders in front of the motor, and it pushes the screw. It doesn't spin the screw anymore, it's just a straight push. So it pushes all of that molten plastic all the way through this heated section of the barrel through a wee little nozzle. Now, there are a bunch of nozzles, and you can pick whatever size you need. Usually, it's determined by the sprue on the back of the mold that you're working on. But it pushes all of that plastic through a wee little hole in the front of the screw and into the sprue on the mold. I'll show you guys that side. Now, this is the meat and potatoes of an IMM. This is the clamp portion. And like I mentioned, this is an older machine, so it actually uses a massive hydraulic cylinder back here. When I say massive, I'm not kidding you. I mean, this thing's probably 2.5, 3 foot in diameter for the rod side of the cylinder, and at least 8 feet long. So this part of the clamp is called the moving side of the platen, and that one is the non-moving platen, or the stationary platen. And platen just meaning this big metal thing that moves. That's where the clamp molds. You know, this is just the nomenclature you pick up in the industry. But whenever you talk to other people in the industry, you better use the same words so they know what you're talking about. But back to the original thing. Once the screw is pressed into the back of the stationary platen and it's held there with hydraulic cylinders, all of that plastic gets pushed through this platen and into the stationary half of the mold, or the sprue side traditionally. The clamp is closed at this point and pushed under tonnage. Usually you set however much tonnage you need based on your shot size and the square inches at the face of the mold, but that's no more science and stuff. Once the plastic is pushed into the mold, it is then cooled with water, or just temperature controlled somehow, either heated water with a thermolator or chilled water from the process, whatever. Plastic goes in here and solidifies. Once the mold opens, it uses some kind of crazy ejection system, whether it be unscrewing cores or hydraulic ejectors or air ejectors or mechanical ejectors. Something has to pull the part out of the mold once the mold is open, or during open. You know, there's a bunch of different complicated stages of getting parts out of molds. But then once this thing is open, you can do whatever you want. Either you have a Cartesian robot come in from the top and pick the part out of the mold, put it on a conveyor, do whatever. You can have a 6-axis robot come in from the side of the machine and do stuff and place inserts and take it out. Or you can just simply have it open and eject down onto a chute, onto a conveyor to do with whatever you're going to do with it. But that is, in essence, wholehearted how an injection molding machine works. Now, guys, I told you I'd show you a little bit newer one. This is a 2021 or 2 high TN, and this is a toggle machine. So what you guys saw back there was a traditional hydraulic ram piston type clamp. This one is what's known as a toggle, and what's responsible for doing the clamping, like the actual pressure, the clamping force on the mold, is all mechanical. I mean, there is one small hydraulic cylinder right in the center that operates the knuckles, but I'll show you what I mean. This is actually a really cool setup. They're not exactly known for their speed, but things have gotten better since toggles were like brought out to the industry, and they can be pretty quick, but the downside is it's all mechanical. It's rods, it's links, it's bushings, there's a lot of maintenance that goes in to keep these things going, because it is just mechanical, metal on metal. I mean, this thing literally beats itself up and takes it to that point where it cams over to lock up, and that's how it works. But on the same thing, they are incredibly energy efficient, because that last machine that you saw, it takes the hydraulic pressure pushing on that mold the whole time it's closed to maintain that clamp pressure. These ones, it's mechanical. Once it cams over and locks out, that's it. The hydraulic pumps aren't running on this machine. So the part is sitting in here on cooling time for however many seconds you have that. They're really, other than control voltage, this machine is utilizing no power during cooling cycle. Once that's done, that little hydraulic cylinder in the middle, it pulls the arms just enough to pull them over center and relax it. And then this thing comes back in, opens, and it starts the whole cycle again. I know this may be hard to see, but this is kind of hard to get to also. This is the toggle mechanism in the back of a toggle clamp machine. So you can see there's 2 sets of arms on the top, 2 sets on the bottom. And right there in the center, that silver dot, that is the rod end of the hydraulic cylinder that operates this whole thing. So if you can imagine, that cylinder in the center pushes out, and these arms want to spread out. And once they get so far, they lock over center and mechanically hold this clamp in the position that you set. Now, guys, I know we may be rambling here, but I'm sorry, but I think this is cool. So if you please feel free to fast forward through this, but I felt like a good opportunity. So now we've gone through hydraulic clamps and toggle clamps. This is yet a different style of clamping for injection molding. This is what's known as a two-platen. Now, if you remember from what I was saying before, platens are the parts that the mold clamps onto. So that's how these things work. There is a stationary and there is a moving. So thus far, we have seen two different procedures or styles or ways to clamp up a machine. This is yet another one. And this is arguably the coolest / newest way in the industry also. So you see these 4 giant rods here. They're called tie rods. That's a normal thing. They are in every machine. Regardless of what style you have, there are tie rods that keep the two platens parallel with each other. That is important. That is a big deal. That keeps your mold from flashing and all about processing. But if you notice, all of these tie rods are like cogged on the end. They're serrated, if you will. That's for a good reason. That is how two-platen machines work. So once this platen moves over the tie rods here with this cylinder, actually this guy's sticking out right here, that one, and there's another one caddy corner on the back side of the machine that are responsible for traversing the moving platen. They're called traverse cylinders. Weird, right? So once those cylinders get your platen to where it needs to be, there is what's called a half nut on the back side of the moving platen. Don't worry, I'll show you. So those half nuts come down around this rod and clamp it into those serrations and mechanically lock the moving platen to the tie bars. Now here's the cool part. Once the tie bars and the platen are locked together, these guys right here, this one's hard to see, it's under a cover, but the tie bars themselves, all 4 of them, are hydraulic cylinders. So they will pull the whole mold assembly together to achieve your clamping pressure. So instead of moving 300 gallons of oil like we did on that first machine to move the whole thing under hydraulic pressure, this thing only has to move those 4 tie bars like, I don't know, 1/4 of an inch or something, just enough to achieve whatever tonnage you're looking for. And that's it. Once it gets there, it meets, like it satisfies its pressure setting and then just sits under a check. So same thing, servo hydraulic. So it meets that pressure, it monitors it, and it sits behind a check valve the whole time the mold is happening. And then, and not only until the molding process is done, the machine sends a signal, hey, we're done, backflow that valve, open it with a pilot, and let this thing fly open. It's actually really cool how this works. These things are super efficient and super fast. So back here, where the magic happens, the man behind the curtain, so to speak. So I mentioned to you those half nuts that are responsible for grabbing onto the serrations of the tie bars. That's these guys right here. There's a set here and a set on the other side. Now, this is just like cars and makes and models. They all do the same thing, but different manufacturers do it different ways. So don't take this as gospel. This is just the way that this one works. So there is a hydraulic cylinder in the center here on like a cam bar setup. So yet again, we're using cams, mechanical locking, so we don't have to sit under hydraulic pressure. Once these things move with the hydraulic cylinder, I'll bring you guys in so you can actually see what I'm talking about. But it will close these clamps and cam over this cam in the center here with these 2 linkage arms. And that's what's responsible for holding these closed during the molding cycle. It's honestly really cool how this works. And the only other stuff that's on the moving platen is the hydraulic ejector system. So some molds use them, some molds don't. It's up to you and your process whether you utilize what's going on back here. But I just think it's really cool how this works. So this guy right here is your hydraulic ejector. So this would be mechanically tied through steel bars through the rear platen into the moving half of your mold. Whenever it opens the whole way, this thing would move in and out, and that's what's responsible for ejecting the parts from your mold. Now this guy here, the half nut linkage that I was talking about, you guys see the serrations on the half nuts that are exactly opposite of the serrations on the tie bars. These guys would index with each other. This cylinder here extends. These two clamshells come together and lock around the tie bar. And after that is satisfied, because via switches and proxies and everything, we know where things are and we know what they're doing. This part right here cams over center, and these bars are responsible for holding that in its locked position. And not until the machine tells it to retract this cylinder, it pulls this back over center, relaxes everything, and it's time to open. Now, I briefly mentioned earlier about getting stuff out of the mold. There are different ways to do it and different processes, and everybody makes their soup their own way, right? So this particular machine utilizes a Cartesian robot to get things out of the mold. Now, in the world of robotics, this is like the most normal thing for this industry. Like whenever you get the 6Xs, it's a lot more cool and a lot more complicated, but it's also a lot more expensive. And you need really well-trained people in your facility to run these things and take care of them. Cartesians are pretty well, you keep them greased, they just run. Once you learn how to do the programming, there's not much to it. So you guys see that big aluminum monstrosity hanging off the end of it. That is called the end of arm tool. Rightfully so, right? It's on the end of the arm and it's a tool. Those tools are specific for the mold that they are running. So that way, this thing will go into the machine, drop down in between the mold while it's open, retrieve the part off of the finished side, come back up, come out here, dump it on a conveyor. It'll go to a grinder, it'll go to a sprue cutter, it'll go to an inspection station, whatever you want it to do. That's the beauty about robotics. It's a dumb hunk of steel. It will do nothing unless you tell it to do it. Believe me, if you tell it to do it, it will do it. Whether you are right or wrong, if you tell it to go from here to here, it will go, and it does not care what's in the middle, whether it be a brick wall or you or your buddy. So robotics are fun, but they're also dangerous. So just if you start messing with this stuff, it is really cool, but mind your P's and Q's. All right, guys, I'm sorry. Now that we've gotten sufficiently off topic for a significant amount of time, I apologize. But, like I mentioned earlier, if you're not into this stuff, it's cool to be exposed to things that you're not normally exposed to. Like if one of you guys worked in like a lime mine or a refractory or something, I don't know, something cool that I'm not used to, you better believe I would sit down and watch that because this stuff interests me. So excuse the sidebar, but I just thought that was a cool little excuse to show you what's going on since the plant isn't running right now. And it's just, we got stuff torn apart and I was already out there. So, hopefully you guys enjoyed, but my bad. Now we're back to this, and you guys, if you remember all the way back when at the beginning of that garbage, I showed you what this was, where it goes, and what it does. So now I can actually bring you guys in and show you what's happening and like what I've done before, what I plan to do again. But, it's as simple as grinding out the bad stuff and welding in some new stuff. So, yeah, let's do it. Let's get this old girl in a position where we can actually work on it. I know this may not be an ideal situation, but, it is what it is. Like I said, this is a solid chunk, and that's kind of the whole point of what I'm fighting here because it's a solid chunk iron, so unfortunately. But let's clamp this old boy up so we can actually get at and work on it. Come on. There we go. And don't worry, just in case the safety police is out in force on this one, this is totally fine. Don't worry about it. So now that I have this thing in an appropriate position where we can actually see and get our peepers on it, I'll bring you in and show you what's going on. So now you guys can see the whole thing in all of its glory. Here we got a rigid steel pipe, and it is just butt welded into this block. There's the factory weld. And there is a weld that I did about 6 years ago to fix this exact same problem. And you can tell by the Sharpie marks on it, apparently that's where we're leaking again. But I tell you what, that thing held for 6 years beating the crap out of itself, so I'm still pretty pleased with it. What we're going to do here is just grind all this crap back out, go ahead and dress up the other side, and we're just going to weld all the way around this thing. Probably do at least 2 or 3 passes. But yeah, that's the point. So let me throw some jams on here, and I'll get to grinding. Well, I think that about does the majority of the fillet there. Now we're going to go around with a die grinder here and get more of the root, but I think that takes 95% of it out. Obviously, I don't want to undo it since this is a fixed pipe and it has to go back into where it is. And actually, that'll take a big part of welding this back together. We're going to have to pay mind to not throw too much heat into this thing in any one particular area. So this thing's going to want to do this crap since it has to go back into where it's going. But I digress. That gets into the crap of welding. But yeah, I'm pretty happy with that. Now we're going to get in there with a die grinder and clean up what's left. Well, man, don't you just love die grinding crap? You know, you're covered in all that man glitter. You'll be finding this stuff in your sleep for the next 2 days. But I tell you what, it's not the prettiest thing in the world, but it is pretty darn good. And if you guys know anything about welding, it's just like painting a car, you know. 10% of it is actually welding. 90% is the prep. You got to make sure that your base metal's clean, everything's good to go. And the cleaner and more prepared your weld area is, the better your weld's going to be. So take the time to do this stuff now so it turns out better then. So I think the next step to this process here, we're going to whip out the oxy-fuel torch and preheat this thing a little bit so as to help minimize the warpage, and it won't, you know, this kind of gets into metallurgy a little bit, but whenever you have a room temperature chunk of iron and you just put all the gigawatts into it, it incredibly changes the molecular structure of the steel because you're changing temperatures so rapidly. So think about it this way. Whenever molecules are hot and warm and loosey-goosey, they're all moving around. They're nice. They're jiving with each other. But whenever they cool down, they kind of like rigid and like solidify where they are. And that's what makes steel steel, is because the molecules are locked in their place so hard that it's a solid chunk. So if we bring this thing up closer to welding temperature before we weld it, it's less of a shock to the molecular structure of the base metal. So yeah, you do that, and then ideally you would want to cool it down really slow. So you would put it in an oven or like a hot sand bath or something to cool this thing slowly so it has less stress in it whenever it cools. But yeah, either way, I'm just talking. Let's just get the torch, huh? Alrighty. Sorry that I got everything out of frame over there, but yeah, there's a whole maze of garbage behind it that you can't see, and I can't get the torch card over here. But either way, we got it. Come on. Ah! There we go. Cool. I think that's at least sufficient to get us going. Now, for those of you that are new to fabrication and welding, so much of this is done by eye. Like, you can actually see the base material kind of changing colors into like a perfect piece of toast, like light golden brown, showing me that my base metal is actually reacting to what I'm doing to it. Like, just ask any body guy out there. The whole thing is done by eye. Yes, you're doing metal work with tools and hammers and torches and welders and everything, but it's just looking at it and knowing what you're looking at. So the longer you do this crap, the more you kind of just get the hang of it. But now that everything is good and sufficiently clean, oh, another cool thing about the torch, not only does that bring us up to pre-welding temperature, but it also ensures that all of the moisture is out of our base metal. Like, I know it's not wet, it wasn't sitting outside in the rain, but I promise you, you put a torch on any piece of steel, it could be the driest piece of plate steel in your shop, put a torch on it, you will get a like wet ring around your flame. That's just the humidity in the air, you know, moisture just sitting on the surface of the plate that you can't necessarily see, but whenever it's induced to a 2000 degree flame, you know, things change state. So preheating whenever you're welding is always a good idea, whether you're actually trying to protect the molecular structure of the steel or just making sure it's dry before you weld it. It's a good idea. But either way, let's get sparking. Now for my next trick. Wow! The Miller multimatic 215. Arguably the best darn machine that you can buy. Are there better? Oh yeah, there is absolutely 100% better. Are there worse? You better believe it. But I tell you what, for what I do around this joint and like at home, farm, ranch, or whatever, I have yet to find a better buzz box than the Millermatic 215. This dude does it all. Now, minus aluminum, but don't get touchy, guy. All right, we can't have it all. This thing does stick, MIG, and TIG all in one convenient little thing that you could literally fit on the passenger seat in your car. This thing runs on dual voltage, 120 or 240, so you get all the ranges of everything. Obviously, it runs better on 240, and that's what we're going to do here today. We are just going to use some 030 solid steel wire, shielded with 7525, and we are going to lay down a good root on this guy. I don't know if I'm actually going to do one the whole way around. Number one, because, we were talking about this thing possibly moving, and the physicality of it. My spine only spins in one direction. So I think we're going to start and stop, and I don't know. We're going to do the best we can to get a good root in this thing, and then do a couple caps, and yeah, let's just do it. All right. Extension cord power. Yep. Turn this bad mamma jamma on. Make sure our tank is on. And check our flow. There you go. Cool. Now everything's running. Another cool thing about this Millermatic, in case for those of you that are new to the realm of welding, this guy is, dare I say and loosely say, idiot proof. This thing has a setting on the front of it that makes it so easy to set up. You just tell it what size wire you're using and what thickness of base material you are welding. And it will set you at what it thinks to be an appropriate setting for the machine. And then you use the dials here for heat and wire speed, and you quite literally dial it in. So this is one thick mamma jamma. I think I'm going to put this thing up to at least 3/8 so we get some solid hotness in there. And, I'll dial it in from there. But I tell you what, 22 volts and 480 wire feed, that's going to be pretty darn close. So, yeah, let's just throw a hood on and get at it. Now, kids, this is a do as I say, not as I do situation. Just like everything you watched your dad do growing up. Just because I'm doing it like this does not mean you should. Just like the disclaimer at the beginning of the video. But got some PPE, got my favorite TIG gloves and an auto dark helmet. Cut this guy off so we know we got a nice end. I'll just start laying it down. Whew! I tell you what, brother, that machine does a darn good job of just like knowing what you're doing. That is a solid root. Like, I'm pretty happy with it. We'll go ahead and finish the other side and put a couple caps on this thing. I think we're going to be done with this faster than we thought. I tell you what, since this is such an important weld and we're trying to hold back liquid here, I'm going to go ahead and grind out my stop starts so I'm sure that there is no slag inclusion or anything between my stop starts. Nice. That cleaned up super well. Let's just keep on going. Give ourselves a new cut on the wire. Keep rolling. Nice. All right. So we got our first one done. Do a little more grinding. Make sure that the toes of that root are good and no slag inclusion. And we will just continue on. So, yeah, more grinding. All right. Let's get right back at it, shall we? Oh, yeah. We're getting somewhere now, kids. Oh, yeah. Tell you what, I think about one or two more passes and we might be done with this here project. I just thought it's, I remembered a long time ago when I was first learning how to weld. The instructor told me, if it sounds like bacon, you're doing a great job. If it smells like bacon, you're probably on fire. Either way, moral of the story, this is doing great. I don't know if I want to do another trip around this thing or not. Maybe just for safety's sake. I don't know. I'm just going to clean it up, take a look. After further review of the repair, we find at least one more weld necessary. Continue welding. First down. I don't know. That's pretty darn good. I mean, it's, I don't know if I'd go bragging about it to your buddies, but I bet you that's enough to finish this here repair. We'll go ahead and clean this up with a flap wheel a little bit, because you know the old saying, grinder and paint make a welder I ain't. So, I'll clean this up a little bit so it looks like a first grader didn't do it, and then, yeah, keep on rolling. Now, guys, please excuse the crudity here, but this is what we got. I don't think it's all that bad. I know this isn't a really good traditional here because you're supposed to start a fillet at the bottom and work your way up. But because I was concentrating so much on this toe, I had a pretty good gap in the middle that I just ground out and filled up with that one in the center so we could get that nice, ramp. But we'll go ahead and clean this up a little bit, review it again, and we might be done here. Well, kids, I think that about does it. Like I mentioned, I wouldn't brag about that one. Tell you, welding is like anything else, man. You get really good at it, and then if you stop doing it, you kind of lose that knack. And it's, I'm not bragging or saying that I'm no Jesse James or nothing, but I used to be a pretty hot stick back in the day, but I did this a lot more often. Now I would put myself in like the ranch farmer category. Like, yeah, it'll hold together. I promise you it'll hold together, but it may not be the prettiest looking thing. So we hit that old girl with the grinder a little bit, let this thing cool down on its own and normalize. So we're going to let it cool down slowly. Don't just throw a bucket of water on this thing because it'll get brittle and hard like right quick. And then, hit a little bit of a, overhaul in a can, a little DuPont overhaul. And, I don't know. I'm pretty satisfied with it. Well, guys, I think that about wraps up this here repair. I know I would like to show you throwing it on and making sure that it works and all that. But like I mentioned, I want to let this thing normalize. So this is the end of the week. I'm just going to let this thing quite literally chill here for a while. Throw it back on Monday. And not to mention, like I said before, that these things have soak time, the injection molding machine. So once you turn them on, they take quite a while before they can actually function because they have to fully heat up and everything. So even if I were to throw this on right now, it would be a while before I could actually function it to make sure that it's good. But I got to tell you, between the before to now, I'm super confident that this thing's going to hold up. And hopefully we can get another 5-6 years out of it, hopefully even longer. But yeah, welcome to the world of industrial maintenance on antique equipment that doesn't exist. Sometimes you just got to pull something out of your butt and hope that it works. And let's be honest, it's metal. This isn't wood. Once you cut it, you're screwed. With metal, if it doesn't work, God forbid that this repair doesn't work, we'll just bring it back in here, grind it out, and do it again. I mean, this is a limitless opportunity. So, like I mentioned, I feel pretty confident about this guy, but that is the beauty about metal fabrication. You can do it again and again and again. And because this thing is so beefy, like this is 1/4-inch wall pipe, and that's a solid like 4-inch chunk iron on the bottom. Like this thing will take some heat before it gives up the ghost. You know what I mean? So, yeah, hopefully you guys got a little bit of something out of this. And yeah, we'll see you next time.